You know, every single day you browse websites, you send emails, you download files, and you just expect it all to work perfectly. But behind that smooth, seamless experience, there's an unsung hero, a master organizer called TCP. Today, we're going to pull back the curtain and see exactly how it tames the absolute chaos of the digital world. I mean, really think about it for a second. We are blasting trillions of bits of information across this tangled global web of cables and routers. So what's the magic that stops all of that from becoming a completely useless mess? What actually keeps your cat video from showing up as, I don't know, a corrupted piece of your tax return? Because here's the thing. The promise of the internet is this instant, flawless connection, right? But the reality is, well, it's messy. The tiny little pieces of your files and websites, called packets, are constantly getting lost in transit or damaged or showing up all jumbled and out of order. It's not a pretty picture. And this right here is what we call the internet's chaos problem. See, at its most basic level, the internet runs on something called the IP protocol. You can think of it as a really bare-bones postal service. It tries its best to deliver your data, but it makes zero guarantees. It's a best effort system, which is really just a polite way of saying it's totally unreliable. So what does unreliable actually look like? Well, for starters, packets can just vanish into thin air. Poof, gone. Or they can take different routes through the network and arrive all out of order, like getting page 5 of a letter before you even get page 1. The data inside can get scrambled, and if too many people try to send data all at once, the whole network can get gridlocked and just collapse. That's the chaos we have to deal with. And this is exactly where our hero, TCP, steps onto the scene. To fix this digital Wild West, engineers built the Transmission Control Protocol. Its entire purpose, its reason for being, is to act as a reliable messenger that sits on top of that chaotic postal service and makes absolutely sure that every single message gets through perfectly. So here's the critical part. TCP adds this layer of accountability. It sets up a stable connection and then meticulously manages the entire conversation. It guarantees that what you send is exactly what gets received, in the right order and with no errors. It basically turns "we'll try our best" into "we guarantee it." And who needs that kind of guarantee? Well, pretty much everything you do online. Without TCP's reliability, loading a web page would be a total lottery. Your emails, they might show up with whole paragraphs missing, and your big file downloads would just be incomplete, useless junk. Every single one of these common applications absolutely depend on TCP to work at all. Okay, so how does it all begin? TCP doesn't just start blindly shouting data into the void. No, it starts with a very polite, very formal introduction. It's called the three-way handshake. And the whole point is to make sure both sides are there, listening and ready to talk before even a single byte of your actual data gets sent. It's basically like a 3-step phone call. First, your computer, the client, sends a SYN packet. That's like saying, "Hey, you there?" The server on the other end replies with a SYN-ACK, which means, "Yep, I'm here and I hear you loud and clear." And finally, your computer sends one last packet, an ACK, that just says, "Awesome, I heard you too. Let's get this conversation started." Only then is the connection officially open. Now, once that handshake is done, TCP's real work begins. This is where it manages the actual data transfer, and it has this brilliant set of tools to make sure nothing gets lost or mixed up along the way, turning that chaotic mess of packets into a smooth, coherent conversation. Its first and most important tool, sequence numbers. And this is just genius in how simple it is. TCP takes your data, breaks it into packets, and then numbers each one in order. 1, 2, 3, 4, just like numbering the pages of a really long letter. That way, even if the packets arrive all jumbled, the receiver knows exactly how to put them back in the right order. But you might be wondering, how does the sender know the pages even got there? That's where acknowledgments, or ACKs, come in. For every packet, or maybe a small group of them, the receiver sends back a little confirmation note. Think of it like a postcard that says, "Hey, I got page 23. This little back and forth creates a fantastic self-healing system. If the sender sends out packet number 24 but never gets that postcard back, it just assumes it got lost in the mail. So, after a very short wait, it just sends it again. Simple as that. No data ever gets left behind. And TCP is also really considerate. It has this great feature called flow control. This lets the receiver basically say, whoa, you're sending way too fast. I can't keep up. Can you please slow down a little?" This stops a powerful server from completely flooding a slower device, like your phone, with more data than it can handle. So Look, TCP has been the absolute bedrock of the internet for decades. But our modern world, it's obsessed with speed, with instant responses, with low latency. And that brings up a really important question. Is this old, reliable hero still the right tool for an ever faster world? Well, enter the main challenger, a newer protocol called QUIC. It is built for raw speed. It has a much faster handshake, for one, but it also solves one of TCP's biggest nagging problems, something called head-of-line blocking. See, with TCP, if one little packet gets lost, everything behind it has to grind to a halt and wait. QUIC is way smarter. It lets other data streams keep going, which is a massive advantage for the modern web. And listen, QUIC is not just some experiment. It's already the engine behind the new HTTP/3 standard, and it's already carrying a huge chunk of all web traffic. Its adoption rate is just skyrocketing, especially on mobile networks where its speed advantages really, really shine. But hey, don't go counting our old hero out just yet. TCP isn't just sitting still. It's constantly getting upgraded with new, way smarter algorithms. Things with cool names like BBR and Cubic that help it perform much, much better on the kind of high-speed, long-distance networks we have today. The protocol is evolving to meet the challenge. So this leaves us with a really fascinating question. For decades, TCP's slow, careful, meticulous reliability was exactly what the internet needed to grow up. But now, new protocols like QUIC are showing us that maybe we don't have to choose between being fast and being stable. The internet of tomorrow is going to be shaped by the answer to this one question. What's the perfect balance between moving fast and never, ever failing?